Hey everyone, so today we're going to dive into a design pattern that is, I think, beautifully simple, but also just incredibly powerful. It's called the Iterator Pattern, and really it's what lets your code gracefully handle pretty much any kind of collection you can throw at it. Let's get into it.
So let's just start with a fundamental question, one that pretty much every developer runs into. You've got a collection of items, could be photos, user profiles, whatever, and you need to go through them one by one. Simple enough, right? But what if you have no idea how that collection is actually stored? Is it a list, a tree, some kind of super complex graph? How do you write code that doesn't care about that underlying structure?
Okay, let's make this real. Picture this. You're building a photo gallery app. At first, you decide to store all the photos in a simple list. Easy. Looping through it is a piece of cake. You just write a standard for loop, you're done. The feature is out the door and everything's working great.
But then, of course, requirements change. They always do. The product team comes up with a cool new Photos of Friends feature. And to make that really fast, the engineering team makes a smart call. They switch from that simple list to a more complex graph structure. It's a great move for performance.
And boom, total catastrophe. Your once perfect little loop is now completely, utterly broken. It has no idea how to walk through a graph. And this, right here, is a classic problem. Your code was tightly coupled to the data's storage. It knew way too much about the internal workings of that original list.
So how do we fix this mess? More importantly, how do we stop it from ever happening again? Well, what we need is a kind of universal remote control for our collections, and that is exactly what the iterator pattern is. All right, here's the official definition. The iterator is a behavioral design pattern that lets you traverse elements of a collection without exposing its underlying representation. Now that last part, that's the magic right there. Your code doesn't need to know and shouldn't care if it's a list, a stack, a tree, or anything else. This quote from refactoring.guru just nails it. The big idea is to pull the how to walk through it logic out of the collection itself and put it into a completely separate object. We call that object, you guessed it, an iterator. This separation is where all the power comes from.
So let's go back to our analogy. The iterator is our universal remote. It doesn't matter if you're pointing it at a list TV or a graph Blu-ray player, the remote works the exact same way. And it's a really simple remote. It just has two main buttons, a next button to get the next item, and an Are We Done Yet button to check if there's anything left. That's it. It's so beautifully simple.
Okay, this all sounds fantastic in theory, but how does it actually work in practice? Let's pop the hood and take a look. And you'll see it's actually surprisingly straightforward. So from your code's point of view, what we call the client, the job becomes incredibly simple. First, it just asks the collection, hey, can you give me an iterator? Then it just uses that iterator in a loop. It keeps asking for the next element and checking if there are any more left, over and over, until it's done. The client has absolutely no idea how the iterator is finding that next item, and it doesn't need to. So you really have three key players in this setup. You've got the client, which is your app's code. You have the collection, which is just holding the data. And then you have the iterator, our new little helper object. Now, the crucial thing to see here is that only the iterator knows the messy internal details of its specific collection. Everything else just talks through a clean, standard interface.
Okay, so we've seen the mechanics, we get the how. Now let's get to the good stuff, the real-world payoff. Why is this pattern so incredibly valuable for us as developers? I mean, this slide really says it all, doesn't it? On the left, you've got the absolute nightmare of code you'd have to write without this pattern. Just this tangled web of if-else blocks for every single collection type. It's fragile, it's a pain to maintain. And then you look at the right, clean, simple, readable code that just works for any collection that can give you an iterator. That is a massive win for your code quality.
And the benefits here go really deep. You're actually following some core, fundamental software design principles. You're satisfying the single responsibility principle. The collections just have to worry about storing data, and the iterators just focus on traversal. You're also meeting the open/closed principle. You can add whole new types of collections and new iterators without ever having to change your original client code. You can even have multiple iterators walking through the same collection at the same time, which is just incredibly powerful.
So, when should you reach for this pattern in your toolbox? Well, it's perfect when you have complex data structures like graphs or trees, and you want to hide all that complexity from the rest of your app. It's a total lifesaver when you find yourself writing the same looping logic over and over again. And just like in our photo app example, it's absolutely essential when you need your code to handle different kinds of data structures in the exact same way.
All right, if you remember just one thing from all of this, let it be this one powerful concept. The iterator pattern is all about freedom. It's about decoupling your algorithm from the data structure. It frees your client code from ever having to know the messy, internal, private details of how data is stored and organized. And that freedom is what makes your code cleaner, way more flexible, and just so much easier to maintain in the long run.
So really, the iterator pattern is just a fantastic example of abstraction. It's a simple remote for a complex device. And that kind of leaves us with a final thought, right? What's the one piece of tangled, complicated logic in your own work right now that is just begging for a universal remote? Where could a clean, simple interface like this tame the most complexity for you?